Very good morning to all my dear students. Sorry. So, today class I am going to discuss about a device called solenoid. So, this solenoid is very simple device that we have seen in our laboratory, that there is a device that acts as a rheostat. So, let us see what is solenoid. A solenoid is an insulated long wire closely wound in the form of helix. Its length is very long compared to its diameter. So, it is nothing but what? It is an insulated long wire closely wound on in the form of a helix. Very simple. For example, take a wooden thing or any insulated cylindrical object. On this, what we are doing? We are wounding the wire around this insulated device like this. So, each wire should be insulated, because if the current starts to flow, what happens? If they are not insulated, it gets short circuit, right? So, now what we done, for example, this pen is a cylindrical object, right? If this pen is a cylindrical object, if you take the insulated wire, this is cylindrical object, understood? So, this is insulator, right, plastic. So, now assume that I have taken this wire and wounded like this. So, this should be insulated. This acts as what? Solenoid. So, here this is thick wire actually. We should take a wire which is very thin and closely wounded loops. Then it is called what? A solenoid. So, what is the function of solenoid? How it works? Let us see. So, what is solenoid? A solenoid is an insulated long wire closely wound in the form of helix. Its length is very long as compared to its diameter. So, this is an insulated object. On this, we have wounded the wire which is insulated. Now, if the current starts to flow, what happens? Each turn what we wounded acts as circular loop. Each turn what we wounded acts as circular loop, and we know that circular loop, how it will be? Let us see. Imagine that this is the upper part of this solenoid. Here and this how it comes, see, like this. So, each turn acting as a circular loop. As we know that circular loop produces magnetic field along the axis. So, if current flows through this wire, each turn of this wire acts as a circular loop, and we can get magnetic field along the axis of each center, right? See, this is one turn, it produces magnetic field at the center, next turn magnetic field. So, we get magnetic field along the axis of the solenoid. So, we can say that clearly that inside the solenoid magnetic field is uniform and parallel to solenoid axis. So, here this is inside the solenoid, magnetic field is uniform. We can produce uniform magnetic field by using device and parallel to what? Solenoid axis, and parallel to what, solenoid axis. So, this device called what? Solenoid. They are going to produce uniform magnetic field that will flow inside the solenoid. Now, how much magnetic field is going to produce inside the solenoid? Let us derive the expression for magnetic field due to a current carrying solenoid. Okay, na? Right. Outside here, magnetic field is 0, because this produces magnetic field and this also produces magnetic field. The net magnetic field outside the axis of the solenoid is what? 0. So, it produces only magnetic field inside. Let us calculate the magnetic field due to this solenoid by using Amperes Circuit Law. So, what we are going to do here? Expression for magnetic field due to solenoid. Expression for magnetic field due to a solenoid. Okay, let us take the solenoid. So, let us take this is cylindrical wire, and you know here the current is moving perpendicular to the plane outwards. Yes or not? The dot represents what ma? Current perpendicular plane of the proper and directed outwards, and here the current is moving inwards. And you know the magnetic field is uniform inside. So, to calculate the magnetic field inside the solenoid, we are placing a rectangular slab. We are placing a rectangular slab so that it forms one closed loop A, B, C, D. So, if you place this rectangular slab and current starts flowing through the solenoid, what happens? We get magnetic field. So, this is the direction of magnetic field or not? Yes, this is the direction of magnetic field. Let small n be the number of turns per unit length. Total number of turns how much? N, capital N. So, n is equals to n by L, that is equals to n is equals to n into L. Consider this equation number I. Now, if current starts to flow here, we can apply Amperes Circuit Law, right? Yes, applying Amperes Circuit Law for closed loop A, B, C, D. Here which is closed loop? A, B, C, D is the closed loop. So, let us apply the closed loop. Line integral of, what is the loop name? A, B, C, D, B bar dot dl. So, this closed loop is divided into how many parts? 4 parts. When AB has the length of the conductor, yes, BC has the length of the conductor, CD has the length of the conductor, DA. See here, line integral of AB, B bar dot dl plus line integral of BC, B dot dl plus line integral of CD, B bar dot dl, finally line integral of dA, B bar dot dl. Now, see ma, here the length of the conductor AB and B are along same direction. Yes or not? This is magnetic field and the length of the conductor is also along the same direction. Next, BC, AD or DA or in which direction? Perpendicular direction. So, integration of BDL can be written as integration of AB BDL cos 0 plus integration of BDL cos 90 plus integration of CD. Here already we said that for a solenoid outside the magnetic field is 0. So, here the magnetic field is 0 dl plus line integral of dA B bar dot dl cos 90. This is 0. Cos 90 0 means this total term becomes 0 and this total term also becomes 0. Now, finally, what is the magnetic field? Only integration of AB CD B dot dl is equals to line integral of BDL due to AB. So, we consider what is the length of this loop? Length of this loop is L. So, from Amperes Circuit Law, what is this value? Mu naught N I, because according to Amperes Circuit Law, line integral of magnetic field loop is equals to mu naught times of net current flowing. How many turns here it has? N turns. So, mu naught N I is equals to line integral of AB into B dl. B is constant. Line integral of dl is equals to mu naught N I. What is integration of dx? X. Integration of dl? L. So, B into L is equals to mu naught N I. B is equals to what, ma? Mu naught N I by L. We already written what is small n? Number of turns per unit length. So, B is equals to what? Mu naught N I. So, this is the magnetic field due to a solenoid. So, what is solenoid? A long cylindrical wire is wounded with insulated wires. It is called solenoid. Its length is long as compared to its diameter. So, this solenoid, in each, if you are wounding the circular coil, each circle or each round acts as a circular loop of one turn that is going to produce magnetic field along the axis of the loop. Outside the solenoid, magnetic field is 0, inside it is uniform. What is that magnetic field has been calculated by using Amperes Circuit Law by placing a rectangular loop. When you place a rectangular loop like this, here the magnetic field is along this direction. So, here the magnetic field and the length of the conductor are along same direction. For this and this perpendicular, this is outside. So, magnetic field is 0. So, magnetic field due to closed total loop is equals to what? Magnetic field due to along the length of the conductor. That only we return, that is in line integral of ABCD B dot dl is equals to line integral of AB B dl. What is this one? According to Amperes law, mu naught Ni. B into integration of dl is equals to mu naught Ni. B into L is equals to mu naught Ni. L if sent there, B is equals to mu naught Ni by L. What is small n? Number of turns per unit length. So, this is the expression for magnetic field due to a solenoid. Next device is toroid. This toroid we know very well, but we do not know the name of that device. Have you seen fans, electrical fans in our home, right? Yes. If you see the shape there, round circle will be there, right? In that, one plastic cylindrical object there if you go for a repair shop, there they wound the copper, the number of turns in that coil explains the capacity of the fan. So, what is the use is that coil produces magnetic field, we are passing current, so that in the presence of perpendicular magnetic field, the fan is moving in circular path. Because we should get it out that if you give current, the charge or any object will experience the force along the direction, means it has to move along straight line. But if you are giving current to a fan, it is rotating because of what? The presence of magnetic field. That device is called what? Toroid. So, what is toroid? A solenoid bent in the form of a circular loop acts as toroid, that is it. What is toroid? A solenoid bent in the form of circular loop acts as toroid. So, we already taken solenoid, right? What is this? This is the solenoid. If you bend this one in the form of circular loop, what it becomes? Is it right? If current starts to flow, what happens? It produces magnetic field where only inside the solenoid, right? So, this is magnetic field. The dotted lines represent that what ma? Magnetic field. So, this is magnetic field. So, this is what? A toroid carrying current. So, there is only uniform magnetic field inside the toroid. The magnetic field lines are circular and concentric with the center of the toroid. Is it right? These magnetic fields are circular and concentric with the center of the toroid. The magnitude of magnetic field is constant because you produce uniform magnetic field and it is 0 at the interior as well as the exterior. So, if you want to calculate the magnetic field, what happens? According to Amperes Circuit Law, if any closed surface enclose current, there exists magnetic field in that region. The interior open space does not enclose any current, right? So, let us derive the expression for magnetic field due to a toroid. Already we derived for solenoid, right? Now we are going to derive for toroid. Magnetic field due to a toroid. So, if you take actual shape, so this is toroid. Here the magnetic current will be perpendicular and out of the plane, because the circular loop the current is travelling outward direction. That is here inside moving into the surface or into the plane. Okay. Now, I consider 3 loops, okay, where one inside the loop that I consider as P, next one Q outside the toroid, this is Q, and one inside the toroid, this is interior, this is exterior. This is S. So, this is Amperian loop 1, this is Amperian loop 2, this is Amperian loop 3. Now, we got how many loops? 3 loops. Let us apply the Amperian condition for 3 loops. So, for loop 1 magnetic field is 0. Why? No current is flowing inside the loop 1. Second loop also no magnetic field, right? Why? It lies outside the loop, no magnetic field exists. So, here magnetic field is 0 because no current is flowing in the loop. Here it produces magnetic field, but the magnetic field due to this one and this one get cancelled. So, the net magnetic field is 0. Now, we have to calculate the magnetic field only for loop 2. So, we will assume that let B be the magnetic field inside loop 3. Okay, magnetic field inside the loop 3. Now as usual, according to Amperes Circuit Law, according to Amperes Circuit Law, line integral of B dot dl is equals to mu naught n into I. Okay, that implies here if you take magnetic field and length of the loop, both are along same direction. So what you can write here, integration of B dl cos 0 is equals to mu naught Ni. That implies B into line integral of dl is equals to mu naught Ni. What is integration of dl? L. What is L here? It is not linear, it is which shape? Circular shape. So integration of dl is equals to L, that is length of the loop. What is the length of the loop? 2 pi r. If you consider the radius of that loop is r, we can write this as B into 2 pi r is equals to mu naught Ni. That implies what is B? Mu naught Ni by 2 pi r. So this is the magnetic field due to a solenoid. Solenoid is mu naught Ni, small r capital Ni by L. Whereas toroid is what? Same field, but it is bent in the form of what? Circular loop. So what is a toroid? A long solenoid bent in the form of a circular loop acts as toroid. It produces magnetic field inside the solenoid, whereas interior of the loop and exterior of the loop, the magnetic field is 0. So what is the magnetic field inside the loop 3? B is equals to mu naught Ni by 2 pi r. So these questions are important for 3 marks. So based on the what is, they will ask that what is solenoid and what is toroid were for mark question, and expression for magnetic field is solenoid and toroid for 3 mark questions. Is it clear, students? Thank you.